Correct. So 127 cannot be a valid IP address. The reason is it is dedicated as loopback address. It is for self-diagnostic test to make sure that our device is supporting networking. We have this. So when we ping this address by connecting on physical wire or connecting to a Wi-Fi, if you will be able to receive an update, sorry, if you will receive a reply, then it means that your 7 layers are working fine. Now, as you said, in IPv6, we just got only one address for this purpose, which is colon colon 1 colon colon 1. Whereas in IPv4, the entire subnet is given for this purpose called loopback address. Lot of wastage. 127.001 is more than enough for loopback. But here we have lot of wastage. We don't have such wastage in IPv6. We'll go more deep into IPv6 when we are in a dedicated topic called IPv6. Let us now proceed. As you know already, class A ranges from 1 to 126, and 128 to 191 is class B. And then 192 to 223 is class C. And then 224 to 239 is multicast range. Though it is called as class D, we don't use this to assign any IP address, any device an IP address. We cannot use this. This is for multicasting. So the IP address for individual device is only class A, B, and C. Now, in class A, we have a private range. Likewise in B and C. The IP addresses of two main categories. One is private and the other one is public. Now, why do we need private? Private addresses are to identify devices with the address which you no need to purchase, which is free for you to use, and this is more than sufficient for private conversations. I repeat, if you have 10 computers in your home and only these 10 computers need to communicate, then you're not dependent on internet. Internet is public network. When you're not dependent on internet, you don't need a public IP address. You need just a private IP address for communication. I repeat, if you only want to talk to public, you need public IP address. Within the organization, you're not going to talk to public. It's your within organization. It is private. So you need only private IP address for communication. If I have 1,000 employees, all these employees can easily talk with themselves, within themselves, using private IP address. But when they go online, what does that mean? When they go online, when you're trying to communicate to the world, to the internet, to the public world, like Yahoo, YouTube. Then you need a public identity. But you no need to provide public identity for every single computer in the organization. We will do translation between private to public, which we call as natting. But that will not come now. We will not talk about that later. We will talk. What I'm trying to say is, if I have 10,000 employees, for all 10,000 employees, I have free IP address. And that IP address is called private IP address. Now, using this address, I can communicate to anyone in this organization. There is no public cloud. There is no internet in between us. All these 10,000 employees or member of same organization. So private IP address is enough. There is no need of paid public IP address. Class A private IP address is 10.0.0.0 to 10.255.255.255. This range is private. And likewise, 172.16.00, 172.31.255.255. Next one is 192.168.0.0 to 192.168.255.255. So this range of address anyone can use. Depending on their size, if the network is too big, they may take 10 network, depending on the size. So private IP addresses are free. Private IP address, you no need to take anyone's approval. It is free. It is free. And to this private IP address, you can do subnetting to have multiple private subnets, which is our next topic. Subnetting is next topic. Now, we need to remember this range. 170 to 16 till 170 to 31. So if I have an address 170 to 14.1.1, it is private. If I have an address 172.33.1.1, it is I repeat 172.33.1.1. So in class A, we have a loopback address reservation and we have private reservation in all three classes. We also have another reservation 169.254, any address. This can be any number. That is what I mean. This can be any number. 169.254 x dot x. X dot x is can be any number in this to update. So this is a special network which is called as automatic private internet protocol address, APIPA. Automatic private internet protocol address, APIPA. APIPA stands for automatic private internet protocol address. Now what is this? Actually, as the word says here, it's an automatically assigned private address. So it's not a public. It is also, see, we saw just now the range of private. But this 169 is not coming in this range. But this 169 is also a kind of private. Why we call it as kind of private? Because this cannot be public. Anything that is not public is private. So all other address except this range, all other except this, all other address except that is a public range, public address. So this one APIPA 169254, it is also private because it's not a public. But this has got some special purpose. You see, giving the address in this range, we will communicate. These addresses are used for communication. But this communication is within the organization because it is private. Can we use this address to communicate within the private network? No. Even though it is called as a private, even though it is called as automatic private IP is what? Internet Protocol address. Even though it is called as a private address, this is not assigned by us. This is not assigned by anyone. This is automatically assigned. Then if I say automatic, you should not think that in the office whenever we go, our laptop is getting an automatic IP address. It is that address? No, it is not that address also. That address is called as DHCP provided address. See, in our office, when you go into our office or anywhere you go inside any wireless internet area, your PC will get an IP address automatically from a DHCP server. What server? DHCP. DHCP stands for Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol, DHCP. So we have a protocol that can assign your computer a unique IP address. What is unique IP address? No one else will have that IP. Only you. And it is only for you. So DHCP is one of the service in the network that provides IP address automatically. But this one which we are talking about is not DHCP. It is APIPA. It is not DHCP. It is APIPA, Automatic Private Internet Protocol Address. It's APIPA. It is not DHCP. Automatic Private Internet Protocol Address is dynamically assigned address. But who assigns? The operating system. The operating system assigns. It is not DHCP assigning. It is not a DHCP assigned address. It is automatic. Generated by the Windows or Linux that you run in your laptop. Automatic Private Internet Protocol Address starts from this range 169.254. The third and fourth octet can be any number, and this is generated and assigned by operating system. Okay, what is special about this address? Special is this cannot be used for communication. Cannot be. So how do you call it a special? There is nothing special in this. Then what about this IP address? Why do we learn about this? If this is not assigned by DHCP, if this is not for communication, then why we need this? 169.254, a PIPA address. Why do we need it? This is to tell you. Who is telling? Operating system is telling you that there is no one to provide IP address. There is no one to provide IP address. In order to tell this, it is using this IP address. So usually we make a computer as a DHCP client. Who is a client? The client is the one which requests a server for some service. Here we say DHCP client, which means this computer depends on DHCP for an IP address. Now, we have many computers in our organization. We cannot manually assign IP address, which is a tedious job, which is a difficult job. So what we do is we just make all the PCs as a client, and these clients will get IP address from a server, a DHCP server. So you will have one or two DHCP servers in the organization. Actually, one is enough for one network. So I have a DHCP server here. One DHCP server is enough for one network. If you have many networks, then for each network you need one DHCP server. You can make one router to be a server for many networks or one network. You can also have a Windows server to act as a DHCP server or Linux server to act as a DHCP server. So what I am trying to say here is a router can also be configured to act as a DHCP server. Now, what is the responsibility of a DHCP server? The server is to provide IP address to the clients. That's the responsibility of a DHCP server. They have to provide IP address to the clients. So the clients get the IP address from DHCP server, after which the users of the client can communicate each other. So if this client need to communicate one another, they need an IP address. Without IP address, can two clients communicate? No. Two PCs cannot communicate without an IP address. PCs need IP address for communication. They need IP address. So who provides IP address? The server. Until the server provides, these two cannot communicate. Now, we have configured as a client, so the client will wait for server to provide. If server don't give, what may be the reason? Someone has offed the router. Someone has turned off the router. That may be one option, one reason. What may be the other reason? This link might have got failed. What may be the other reason? See, we will have a pool of address. Let's say you have 200 address in the pool, 200 IP address. But you got more computers now. Let's say you got 220 computer. Already 200 computer is given, 200 computer given one IP address each. So this 20 computer, no? cannot have IP address. Why? There is no IP address in the pool to give. You understand? So hmm, that is the time period in which this APIPA will appear and tell that I'm not getting IP address. You understand? The 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 situation, the scenario in which APIPA will work is when a client is waiting for a server and when it times out, when it is timed out, when the waiting is too long, operating system will automatically generate IP address starting with 169.254. It starts with 169.254, automatically generates, and this computers all will get IP address, one each. And this IP address 169.254 cannot be used for communication. It is only to signal the user that something is wrong with the server. Server is not giving me address. Got it? Okay. If you try assigning this IP address, it will say this is an APIPA address. Don't assign. 169.254 is reserved for this purpose. Okay. Now, before we get into the other IP related topics like subnetting and so on, let us finish this DHCP topic, which is an interesting topic. Dynamic, I think I already wrote the abbreviation, Dynamic Host Configuration Protocol. What does APIPA stands for? What does APIPA stands for? So, Dynamic Host Configuration Protocol, DHCP. This is to provide IP address to the devices which is in need of IP address. And we are going to see how it works. Let us assume that we got some 500 computers. Assigning all these computers one IP address manually, very difficult job. So you have to turn on each device, wait for the device to boot, and then log in, and then go to the network interface card. See, like this, we used to go here, and then we say right click, open network connections, and then we will go down, and then we will say change the adapter option, and then we will right click, and then we will say properties, and then we will go to IPv4, and then we'll go to properties again, and here we need to type IP address. Doing this for a 500 computer is not easy. Sometimes what we do, we make mistake while typing. Sometimes what we do, we put the same IP address for many devices, more than one device, unknowingly. Unknowingly, we give more than one IP address, more than one device the same IP address. So what I'm trying to say here is, assigning IP address manually is not good. That's what I want to say. It not only takes your time and effort, it not only takes your time and effort, it also uh, opens possibility for making mistakes. We may sometimes give different computer, same IP address. Sometimes we will leave some IP address. We think that, oh, we have already given this IP address. And we will skip some IP address and will run short of IP address later. And yeah, so the best option is, you see, punch this one. Don't say use the following, just punch this. When you select this, what is the option we are trying to use? We are saying we depend on DHCP. When you punch this, you make this computer as a DHCP client. Okay, DHCP client means only that much. When you go and say obtain IP address automatically, this all becomes what? DHCP client. Obtain IP address automatically. I just showed you, right? How to do that? Yeah. When you click on that, it becomes DHCP client. Now all these computers are DHCP client. And let's say we have a server here, a router. See, a router can be a server, or you can also use a Windows server, or you can also use Linux server. So you can use any option. Like if you have a Cisco router, you can configure Cisco router to be a server. If you want a Windows machine to be a server, yes, you can configure Windows machine to be a server. Because we are in Cisco class, we will learn how to make a router to act as a DHCP server. Or Cisco networking, Cisco router. So what does Cisco server means? What does configuring DHCP server on Cisco router means? It means that Cisco router will provide IP address for all these clients. If you make a Windows server as a Windows server as a DHCP server, that will also do the same job only. You can use any one. You can use any one. I can make a Windows server to provide an IP address. I can also make Cisco router to provide IP address. Now, what is next is we got a Cisco server to provide IP address to this client. But we need to understand who initiates this. Will server go and give IP address? Take it, take it, take it. You take one. You also take one. Why are you standing? You also take one. Come, come, come. You also take one. Will it be like that? No. We need to understand how this assigning of IP address happens. Who starts the conversation? Who initiates this DHCP conversation? We need to understand this. For that, I would like to draw like this client server. First is client only will send a layer 2 broadcast. Layer 2 broadcast. Client will send a layer 2 broadcast. To whom? Broadcast means what? No, no, no. What is broadcast? Ah, it is a layer 2 broadcast. Client is sending a layer 2 broadcast because you don't have an IP address. You should understand. Client don't have an IP address. Without IP address, how can you do communication? So no communication here. That's why it is layer 2 broadcast. It's a layer 2 broadcast because there's no layer 3 address for devices here. These PCs, these clients don't have IP address to communicate. So what do? They send a layer 2 broadcast. This is a broadcast because it is a broadcast, as you said. It will go to everyone in this local area network. It will go to everyone in this local area network. Fine. But what is the use of sending to everyone? It is sending to everyone because it do not know where is the server. So it is sending to a broadcast address it takes to everyone. Now all other PCs will ignore because they are not servers. See, broadcast goes to everyone, right? Only this guy will say, oh yeah, I'm a server. I can give you address. So the server is now trying to give address. Again, the server cannot use any IP address because server do not know the IP address of this device. This device don't have an IP address. So this is also going to be a layer 2 broadcast. Now, what is there inside this response? Inside the response, it says my IP is, let's say this IP address is 10.0.0.1. It'll say my IP is 10.0.0.1. I can provide you an address if you want. I can provide you an address, let's say 10.0.0.20. It is promising, it is proposing one address. The server is proposing an address saying, if you accept me as a server, I can provide you this address. Now, client will say, yeah, okay, I want you to provide me an address. I'm okay with the 10.0.0.20. I'm okay with that. Can you please provide? And server will say, yeah, you can take it. You can take it. But wait a minute, before that, I want to register you. What is your MAC address? Okay, you are AAA. Fine. I'll make a note. To AAA, I have given 10.0.0.20. So this is what called as binding table. Binding table. What binding table? DHCP binding table. So the server will maintain a binding table in which it will have a mapping of MAC address of the client and the address that is given to the client. Here. So this mapping is found in binding table, DHCP binding table. All right. Now this table is where it is on the DHCP server. We can even see that. Okay, I'll show you. We can even see that. Now this 4 conversation, no? First, who started? Client. That we call it as discover packet. It is trying to discover the DHCP server. It is trying to discover DHCP server. So it's sending a layer 2 broadcast. It is sending a layer 2 broadcast. Why? It wants to find a DHCP server and request for an IP address. Yeah, and it is without IP address, so it is going to be a layer 2 broadcast. Now the server learned it, means the server receives the discover packet and server is responding back, no? Server is responding back to client. We call that as offer. Server is offering an address. It is proposing, it is promising. It says, I am 10.0.0.1, I am a server. I can give you this address if you like. Now for that, client has to reply back. We call it as request. Client is sending a request. Yeah, give me the address. I'm okay with the 10.0.0.20. I like it. Give me the address. Approve for me, please. So that is what called as a request. On receiving the request, server copies the MAC address of the client and grants the address which it has earlier offered. that is called as acknowledgement. All right. So DHCP is 4 packet: discover, offer, request, and all these are broadcast only. Because you don't have an IP address till the acknowledgement comes, client cannot use the IP address. So all these are only broadcast. Layer 2, broadcast. Discover, offer, request, and acknowledgement. Yeah, super. Now, to understand this in an order, or to remember this 4 packets in a sequence, we used to call it as DORA process. DORA. DHCP follows what? DORA process. Discover. Oh, that's all. DORA. So DHCP means most of the people will immediately say DORA. So DORA is what the steps, the process of getting an IP address from the server. All right. Now I'm going to do and show you this, but I'm not expecting you to know the commands which I'm going to type now. I'm just going to demonstrate the DHCP. Okay. So we got 3 computers and we want IP address to be assigned. So you see, I go here to desktop and then I say get IP address from DHCP. But do we have DHCP? No. So what it is doing is it is requesting, and then now DHCP failed to respond. So what has come here? A PIPA has come here. You see, it has automatically generated one address. Whenever DHCP is failing to give, again, you see, I go to another computer. I say, see, right now it is blank, but now I click on DHCP. See, it is requesting IP address. If no response come, it will look at this 169.254. Automatically it comes. Again, DHCP. Yeah. See, no offer comes, so it time expires. So it is showing this. Now let us go and configure this as a DHCP server. As I already told, I'm going to make this one with an IP address, configure this one with an IP address 10.0.0.1. Just for your reference, I'm writing here. I'm not configuring now. This is just for your reference. This is not configuration. This is just reference. Now let me go to configuration and configure the same. Enable config T. I want to give a name. I want to give us a DHCP server. Any name I can give. Giving then interface G000 no shed IP address 10.0.0.1 255 255.255.255.0.0.0. Okay. So what I have done so far is I went inside this interface and I have given this IP address to this interface, to this port. That's what you see here. I went inside this interface and I brought the interface up. It was shut down. So I say no shutdown. I brought it up. And when it has come up, I have given an IP address. So for DHCP server configuration is not done. It is not yet done. Let us do DHCP configuration. IP DHCP, then give a name. I'm going to give ABC as a name. And then network, wait a minute. IPDHCP pool, sorry. IPDHCP pool, and I give a name, ABC. Now I'm inside the DHCP configuration mode. Now I can say network that I want to use is 10.0.0.0. Okay, mask also we need to say. Mask. Okay, net mask straight away, 255.0.0.0. So this is the network from where it should give IP address. This is the pool I have created. I'm saying any IP address from this network. And And what about the gateway? The default router address is 10.0.0.1. This is the address of the router, which is going to be a gateway for this computers. What is a gateway for computer? The address of the router is the gateway. For all this computer, who is the gateway? The router. So I'm saying give your own address to the computers as a gateway. Now, for computers, we also need to give DNS server to go online to resolve the domain name into IP address. We use DNS, domain name server, which is Google address 8.8.8.8. We'll talk about these DNS and all later in detail. Okay? But these are the things that a DHCP will provide to client. Fine. I have finished configuring. Now let us type this command show IP DHCP binding. See, it has already given 3 address to 3 computers by registering the MAC address. These are the MAC address of those 3 computers. Let's go and check. See, earlier you did not have IP, you had only APIPA. Now you see you have a valid IP address. You also have a DNS address. You also have a gateway. Now go here and check. This don't have a DNS server. Let's refresh. It will get it now. You see, it has got DNS 10.0.0.2 mask. Then okay, let's go to the next one. This also don't have DNS. Let's refresh again. Yeah, DNS is important only if you are going online, internet, web page, in order to get the web page. For other communications, you don't need DNS. Okay, so now this is the IP address of this PC 10.0.0.3. Let me go to the other PC and try pinging 10.0.0.3. Ping 10.0.0.3. I'm able to ping. Yeah, so we have assigned IP address to all the PC using DHCP server. You understood?